Hello again. We're still talking about simplification of exponents. Everything we're talking about so far only deals for multiplication, not addition. If you see addition somewhere, it involves a different rule. For example, if I have 3 plus 3 plus 3, we're not going to use the exponent rule like 3 to the power of 3, because this will be totally wrong, because 3 times 3 is 9, 9 times 3 is 27. This will be 27, but 3 plus 3 plus 3 is going to be 9, right? 3 plus 3 is 6, 6 plus 3 is 9. The way you deal with addition, really, you count how many. 1, 2, 3, so it's 3, parenthesis 3. So same thing here. If all I was doing is adding, it's not going to be an exponent. I'm adding 1, 2, 3. 3 A's. So you write this as 3 A's. If it was 2's, 1, 2, 3, 3 2's. 3 times 2 is 6. Now if I was to multiply the same number, then I would use exponents. I just have to bring that up because so that everybody knows that multiplying numbers and you have the same base, you can write it as an exponent. Now if it was something like 5 times 3, there's no base, so you cannot write it as an exponent. So this is just 5 times 3, or you can write it as 15. Same thing if I have m times n, you cannot use it as an exponent. You will just write it as mn. So as we will see later on, these rules will come and help us. Now, after that, we're going to talk about simplification. Now, simplification might seem kind of complex, but if you remember how you used to simplify fractions, it takes about the same steps. Now we have 48 and 42. We're going to write it as in prime factorization, right? It's going to be 2 times 2 is 4. 4 times 2 is 8, 8 times 2 is 16, and 16 times 3 is 48. This one is going to be 2 times 3 is 6, 6 times 7 is 42. So when we divide it, we're going to spread it out into their prime factorization. Now, this is only for multiplication and division. Like I said earlier, all the rules that apply for multiplication is not going to apply for addition. So if I had 2 plus 2 over 2 plus 2, we're not going to simplify it like I'm simplifying it now. So now I can cross out 1, 2 in the numerator and 1, 2 in the denominator. 1, 3 in the numerator, 1, 3 in the denominator. Now what do I have left? I have 2 times 2 times 2, which is 8 over 7. Now, of course, you can say there are other ways you can do it, because 48 and 42, I can divide both of them by, let's see, 6, right? 48 divided by 6 is 8, 42 divided by 6 is 7. So I divided both of them by 6. And 6 in this case is the biggest factor. But I just wanted to emphasize that we could have done it using exponents. Now if I was to do it using exponent, it would be 2 to the power of 4 times 3 over 2 times 3 times 7. Now because they have the same base, we can subtract the exponent. 2 to the power of 4 and 2 to the power of 1. 4 minus 1 is 2 to the power of 3. Now because they both have the same exponent, 1 minus 1 is 0, so they cancel out. Over 7. 2 to the power of 3 is 8 over 7. So all of a sudden, we have used the exponents rules to simplify 48 over 42. And you can use any number using prime factorization. You can use it to factor using the exponent rules. Alright, so the first one I'm going to talk about on how to kind of simplify exponents. Whenever you have a case like this, you always multiply the constants with the constants. So in this case, 2 times -3. 2 times -3 is -6. Now f squared times f7, we're going to use the exponent. All right, we just talked about it. If I was to write it, if I was to spread it out, it's going to be f times f. And then I'll have f times f times f 7 times. If I count all the f's, I have f to the power of 9. And then m is by itself, so this will be the answer. Now for 5 to the power of -7 over 5 to the power of -3, there's two ways of doing it. I can subtract, right, the exponents, because this is division. So -7 minus -3, which is -7 plus 3, which is -4. 5 to the power of -4. Now I can, if you remember, we can switch it out because this is a negative exponent, right? So if I bring it up, it's going to be a positive exponent. I can switch between numerator and denominator and then changing the power of the exponent. So if I do that, it will be 5 to the power of -7 times 5 to the power of 3. Now because it's multiplication, now I'm going to add -7 plus 3 is -4, 5 to the power of -4. See, this is just an example that as long as you use the power rules, you should get you should get the same answer. Now, of course, there's another way of doing it also. Let's say I want just positive exponents, so 5 to the power of -3 will go up, so it becomes 5 to the power of 3, and 5 to the power of -7 will go down, so it becomes 5 to the power of 7. So both of them are positive exponents. Now 3 minus 7 is going to be -4, so 5 to the power of -4. So I've just used 3 different techniques to solve it. Now the next one is we're going to do is 3 times 8. We multiply the constants with the constant. 3 times 8 is 24. Now we add the variable that have the same base, so m to the power 3 times m, so 3 plus 1 is 4. As you remember, if there's no exponent, we assume we know it's 1. N squared times n to the power 3 is n to the power 5. We add the exponents. So, and same thing here also, when you see division, you always look at the numerator first. Can you simplify anything in the numerator first? Then can you simplify anything in the denominator? So now we gotta go across numerator to denominator. So a to the power of 2 divided by a to the power of 2, a to the power of 4 divided by a to the power of 2. So we subtract. 4 minus 2 is 2, and then 6 minus 1 is 5. Or yeah, as long as you write it a squared c squared, this is fine. Okay, now every time you have to evaluate a number, see, you cannot evaluate 3 to the power of -2. It's best you write it as 1 over 3 squared. That way you get rid of the negative exponent, which is 1 over 9.